problem set number 4, question number 5. So this is the first time we're really getting into the nitty-gritty of applying the properties of the normal distribution. So even before we get going, I think it's worthwhile attempting to draw a normal curve, so we can go play with that. That is not a particularly good one, but good enough for our purposes. So for the normal distribution, t-distribution also, right there in the middle, this is just getting worse and worse, we have the mean. So the mean, sample mean is often x bar. If we talk about the population mean, it's mu. So that's supposed to be in the middle. And then over here, we have +1 standard deviation. And over here, we have +2 standard deviations. And on the other side of the mean, we have -1 standard deviation. And symmetrical to all of this, even if it's not in my diagram, we have -2 standard deviations. So we had learned about kind of a shortcut of things that hopefully gives us a little bit of intuition on how far away from the mean we're talking about when it comes to either sample means compared to the population mean or observations compared to a sample mean, that kind of thing. And that rule of thumb is the 68, 95, 99.7 rule. And so it says, if we get a green highlighter going, that between -1 and +1 standard deviations, so in here, this area will contain 68% of the observations, assuming that they follow a normal distribution. So this is all theory. If they follow theory, 68% of the observations will be between -1 standard deviation and +1 standard deviation. It makes sense then, following the kind of rule here, that if we expand this out to -2 standard deviations and +2 standard deviations, we now increase to 95% of the data. So 95% of the data is in between -2 and +2 standard deviations. And, of course, then, if we were to go out to 3 standard deviations, we would include 99.7% of the data. So in our particular question, we're looking for 95% of the data. Well, that's handy because we have part of our rule for 95%, and that 95% is at plus and minus 2 standard deviations. So we know that 95% of our data, what we're looking for, is within 2 standard deviations. Well, up here, we've calculated what a standard deviation is. So if we multiply that by 2, it will tell us how far we need to go. So our upper bound then is equal to the mean, which we calculated, plus 2 times our standard deviation, and that is the upper bound. And similarly, if we have our mean, 167, and we go minus 2 times our standard deviation, that's our lower bound, and that will include 95% of the data. That's kind of the shorthand version using the 2 standard deviations and 95% rule. Strictly speaking, it's not actually 2 standard deviations, it's not 2.0. We can, and generally good practice to use something like an Excel function where we look up table and see what it actually is, what it is exactly. That particular Excel function is norm.s.inverse, so we're talking about the normal curve. The S means it's a standard or a standardized curve. Notice when we look at what we put over here, we don't have a mean, we don't have a standard deviation, we don't have a sample size. So that S implies we're talking about just a generic normal curve. And the dot inverse means instead of asking for a probability, we want a threshold. We want a value. Really, we want a z-score. We want a critical value. Any of those things. So we plug this in. Since we don't want a probability, we have to give it a probability, and that's what this is. Notice that even though we want 95% of the data, we're using 97.5% in our function here. Why is that? Well, because we're talking about a symmetrical lower and upper value. So we have some empty space here and we have some empty space over here. So the sum of those empty spaces needs to be 5%. So we're including 95. That leaves 5% left over, and we need to take that 5% and split it evenly to the left and to the right. So if we have that 5% or the 95%, depending how you want to think of it, and we need to split it in half, that leaves us with 97.5 from the left all the way up to here. So that's 2.5% over there. That's kind of what the Excel function needs. It always calculates from the left and up. So we need to leave that last half of the 5%. So we plug in 0.975 and it tells us, well, instead of 2.0 standard deviations, it's actually 1.96 standard deviations away. And that is what gives us a total of 5% or 2.5% on either side. We still apply it the same way. We take our mean and we're going to add, instead of 2 standard deviations, we add 1.96 standard deviations times the standard deviation. So if we take the mean and we add that, we get an upper bound. If we take the mean and we subtract that, we get the lower bound. And those bounds will contain, in theory, 95% of our data. Hopefully that made sense. We'll do it again in a second video coming up on question number 6.